It's time, the time you've been waiting for. We're learning absolute value functions. I know we're all excited, but please focus and learn from this video. When we graph our parabolas, we identify the vertex. We don't use the pattern. We use a table of values. But you could use a pattern if it makes sense to you. All right, so letter A. Our vertex is at 4, 9. Opposite inside the parentheses. And then the number outside chilling by itself. So 4, 9, way up here. And it's a negative in front, so it flips. But let's see. Let's plug in 2 and 6. So 2 minus 4 is negative 2. Negative 2 squared is 4. 4 times the negative that's out front already. Negative 4 plus 9, 5. So we graph those 2 points, 2, 5, and 6, 5. Connect them. We got our parabola. Domains, of course, for parabolas is always all real numbers. The range is not. The range stops, or the highest point it goes to, is 9. Now, are there points above 9 or below? Well, it's below, so it has to be less than. Whoop, or equal to. The transformations that took place. Usually, we're at the origin. So, whoop, we went 4 to the right, 9 up, and we flipped upside down. Just like what we did last semester, nothing different. All right, let's look at letter B. Our vertex is negative 3, comma negative 7. Remember, it's the opposite of inside the parentheses, but the last number is just by itself. So negative 3, negative 7. We got a point. Now, we need to plug in some points so that we can get our y values and plot the parabola. So if we plug in negative 1, negative 1 plus 3 is 2, 2 squared is 4, 4 times 2 is 8, 8 minus 7 is 1, and so is negative 5. So we can graph those points. Negative 1, 1, and negative 5, 1 as well. All right, so domain, again, all real numbers. Our lowest point was negative 7, and all our values were greater than that, so we have greater than or equal to for negative 7. For the transformations, we did 3 left, 7 down, and narrow because of the 2 out front. So just a review of how we're graphing our parabolas, because absolute values are very close to the same type of thing. So let's continue on. Graph the absolute value function. What are the features of the graph? Make a table of values and graph the absolute value function. So in our regular, either y equals the absolute value of x or f of x equals the absolute value of x. It doesn't matter. Whatever number you plug in for x, it's going to come out as a positive version of it, at least with this one. So that's why when we plug in negative 2, absolute value of negative 2 is 2. So it's 2 now. Negative 1, absolute value of negative 1 is 1. Absolute value of 0 is 0. Absolute value of 1 is 1, and 2 and 2, and all the positives are pretty easy. So we can graph 0, 0, negative 1, 1, 1, 1, negative 2, 2, 2, 2. Notice it kind of looks like our parabola, except they're all on a straight line. There's two straight lines coming in here. So we could go another one, 3 and 3, 4 and 4, negative 3 and 3, negative 4 and 4. So it looks like this. It looks like a V. Our vertex, what's that, 0, 0. Axis of symmetry, well, it'd be the same thing, x equals 0, just like we saw last unit. Axis of symmetry is x equals the x-coordinate of our vertex. What are the domain and range of this thing? Well, domain, it goes all the way to the left and all the way to the right. So it's all real numbers. But it doesn't go all the way up and all the way down. So we have a lowest point at y equals 0. Now, are y values above it or lower than it? Well, they're above it. They're greater than or equal to. So that's our domain and range for this function. We'll keep on moving. Tell whether each point is on the graph of f of x equals x, or absolute value of x. If it is, give the coordinate of another point with the same value. So basically, we need something that's the same, or something where the first one is negative. So 7, 7, that works. Negative 16, 16, that works. Negative 5, negative 5, no, we can't get a negative out of the absolute value. So, another point we can put on 7, 7, we do negative 7, 7. And negative 16, 16 would be 16, 16. So these are really your only two options for a regular f of x equals the absolute value of x. They're either the same number, or the first one's negative and the second one's positive. Tell whether each point is on the graph of f of x equals the absolute value of x. If it is, give the coordinates of another point. So it's the same thing. Negative 10, 10. Yep, that works. We plugged in a negative 10. We got a positive 10 on the output. So we also could have put in positive 10 and got 10. Negative 29, comma negative 29. No, we can't have a negative 29 for our y. Our range was 0 and up. And 18 and 18, yep. Our other one would be negative 18 and positive 18. Because again, these are really the only options. All right, transforming absolute value functions. How do the domain and range of g of x equals 2 times the absolute value of x compare with the domain and range of f of x equals the absolute value of x? So we're looking here, we got our regular absolute value of x here in the black. And then we have g of x, our new one, in the orange. And look, what's the difference? This is, let's see, put this in a better way. The 2 made the function narrower, or a vertical stretch, although we don't really use that. And the domain doesn't change. It's still going all the way up, all the way down, or all the way left, all the way right, just not down. Now, last unit, when we were looking at our quadratics, A was kind of like slope. In this case, A is the slope. So here, g of x equals 2 times x. 2 is our A. So from the origin, up 2 over 1. Up 2 over 1. Up 2 over 1. So absolute value functions are really two lines put together. How do the domain and range of h of x equals -1 times the absolute value of x compare with the domain and range? Okay, well, in our regular one, like we said, all real numbers for our x's on regular absolute value of x, y is greater than or equal to 0, just like we put before, whereas h of x, which equals -1 times the absolute value of x, is our flip. So all real numbers is still the domain, because it's still going all the way left, all the way right. The part that changes is the range. So now the range is less than or equal to 0. So it flips it. It changes our range to the complete opposite side of our graph. So that's what's coming there. How do the domain and range of each function compare with the domain and range of f of x equals absolute value of x? Well, these are still all v's, because that's what absolute value is. So in letter A, our domain is still going to be all real numbers. In letter, or I won't go on to that yet. Then the range, because it goes up, it's a regular absolute value. Y is greater than or equal to 0. So they're the same, but that 1/2 makes it wider. The second one, we kind of already did this one, but still all real numbers for our domain. Our range changes because of the negative, not because of the 2. It's because of the negative. So y would be less than or equal to 0, because it flips everything. And it would be 2 narrower, or 2 times narrower. Interpret the graph of a function. J rides in a boat from his home to his friend's home in the neighboring state. The graph of the function d of t equals 30 times the absolute value of t minus 1.5 shows the distance of the boat in miles from the state line at t hours. Assume the graph shows J's entire trip. So we got, starting at 0 time, we went down to 0 distance, then we came back up. So it's decreasing to begin with, it's increasing, and the minimum is at 0 here. So that's what we're going to be looking at. How far does Jay travel to meet his friend? Well, he went from 40 all the way up to, or I guess it's 45, and 45 here. So 45 plus the 45 gives us our 90 miles. How does the graph relate to the domain range of the function? Well, our domain, it's time. So already time has to be greater than greater or equal to t, not x this time. And it's got to be less than or equal to, well, what's the biggest time we have on here? 3 seconds there. So time's got to be between 0 and 3, because we can't have negative time. The range. Well, it's d of t, or y, is less than 45, because that's the less than or equal to 45, because that's the highest point on this absolute value. It doesn't keep going on here. It started and stopped because it was a word problem. So those are a little bit different. Let's try another one. A cyclist competing in a race rides past a water station. The graph of the function d of t equals 1/3 times the absolute value of t minus 60 shows their distance from the water station at t minutes Assume the graph represents the entire race. What does the graph tell you about her race? Well, here, 20, here's 20. I don't have to write that again, it's already there. So that means throughout this whole thing, we went to 20 twice. So they traveled 40 minutes. In kilometers, oops, I had that backwards. That's 40 kilometers, silly. And in the time, these are all by 15, so this would be 120. So it traveled 40 kilometers in 120 seconds. So pretty fast. Let's talk domain and range. Again, domain, all real numbers. The range, y, is greater than or equal to 0 because it doesn't go negative because we can't have negative distance. I guess, oops, let me go back and change those. Domain's not all real numbers because it doesn't go past those points. So it has to be greater than or equal to 0 and less than or equal to 120, just given this information. Same with the range. Our d of t, or y, or f of x. It's going to be bigger than 0 because it has to be positive, but it can't be bigger than 20 because that's as far as they went away from it, 20 and 20 there.